Hey everyone, how's it going? Today I'm going to be sharing with you a script that I've made for regression analysis. This channel isn't going to be about teaching you how to code. You don't need to have any coding experience. Just as long as you can use Excel, you'll be able to do it. I'm not also trying to teach you regression analysis. Three things we're going to cover today. Number one is going to be the simple regression analysis. Number two, I'm going to show you how you can use this to do predictions on new samples. The third thing that I'm going to give to you guys is a validation script. All right, I think we'll get going now, and yeah. All right, so the first thing you're going to want to do is you're going to want to download the regression zip file that's on the Dropbox link in the description. Extract it, open your regression file. So in this file, you're going to find 3 Excels and 1 rStudio script. So let's just open up regression here. So this is the script for the 3 different analysis types. The first thing you want to do here is to install these packages. So if you just highlight all of this and click run, and these packages will be installed. Open up this Cal Excel. Here we have 2 columns. We have a column Y, and we have a column X, so you can put your own data in here. So yet you have your X column and your Y column, so your response variable Y. So now if you select all of this here until it says end, click run, it's going to begin. One of the first things I want to go through is a file that's going to be generated called results model. So if you open up this file, you have many different stats here. You have your R squared, you have your residual square error, you have your RMSE, you have your B coefficient, you have your y-intercept, you have your degrees of freedom, and you have your p-value. If we're looking at the residuals, the distance from each point in y from the regression line, we're looking at the root mean square error. This is good when you're trying to describe the fit of this data set. When you want to use the residual square errors, extrapolating this data onto a bigger population. So you're trying to use this subsample to make claims or make an extrapolate about a bigger population. That is going to be devised by n-2 instead of n, which is going to give you a more conservative number, higher number than your root mean square error. But if you're only trying to get the fit of this regression, you can use root mean square error. So the next thing we want to do is the script to predict y with this regression model that we just developed if we have an x variable. So you're going to be using your b coefficient and your y-intercept to determine a y value with an x value that you already have. So if we open up the Excel, this Excel is going to be called cal.predict. So we just have the one column here, x, to predict a new sample with your previous model that you built. We close that, and then we run the script. Go up here and click run. Now you'll have a new Excel sheet called results predictions. Open up this Excel sheet. You'll see that you have your original X used as input, and then you'll have this new column called predicted Y. So this final one is a validation. So this is using your predicted values and comparing them to an actual value. In this example, so we open up the Excel sheet called val. We have a column called predicted Y, and we have a column called actual Y. So what you might recognize about this is actually the numbers from the second part of our analysis when we did a prediction. Put your own in here if you're just trying to run a validation, predicted versus actual. Click save. So you grab all of this chunk of code here and you run it. Things will happen. Now we have another plot. This is a predicted versus actual plot. We also have some stats regarding this analysis. So there'll be a new Excel that is called results validation. If you just open that up, you'll notice you have different values in here. You have R squared, your correlation. You have your root mean square error of prediction. The model actually did surprisingly well. It was actually more accurate than root mean square error of calibration. It's actually lower. So the bias as well, it was a slight under prediction. And then this is the SCP, so this is the root mean square error of each individual residual if we subtracted the bias, which is a bit of an optimistic term. For future plans, I want to do our script for ANOVA, both one-way and two-way ANOVA analysis, and also the post-hoc testing. Fisher's least significant difference, Tukey's honest significant difference, and Bonferroni, the 3 more popular post hoc analysis techniques. The general concept of this channel is to be giving scripts out for free, so you don't have to rely on paid software or licenses from your company or your university. You can run all this stuff at your home for free, open source. I'm going to be giving out scripts for many other things, more advanced analysis, multiple linear regression, partial least squares regression, principal component analysis, principal component regression. I'll probably even delve deeper into that. We might look at scripts for doing GIS, spatial significance sort of mapping in here as well. And basically whatever you guys want to see. If you guys want me to write a script for something that maybe you don't think you could do on your own, just let me know and I can try and see if I can tackle it and give it to you guys for free. And alright, well, thank you very much for watching, guys.